Hello everyone. Good afternoon. My name is Raghavendra Ankanna, a graduate student at Arizona State University. I'm currently working as a component design engineering intern at Intel Folsom. The topic for today's presentation is comparison of Intel's processors over other companies' processors. I would like to take this opportunity to thank my professor, Dean Kashiwagi, for referring me this course and helping me choose this project, which helps my professional career. So moving ahead, let us consider the problem statement of my presentation. So Intel stated that it would release a 14 nanometer technology based processor in 2015. So what is a processor? A processor is a unit in a computer which performs various operations such as arithmetic, logical, or any operations that you ask a computer to do. So what was special about this 14 nanometer technology? We'll see that in the subsequent slides. So put together in simple terms, Intel stated that it would release a better processor which is more power efficient, which is fast, and which has superior characteristics to its previous processors. So next. So what are the current requirements in the industry? So if you ask a client or a customer who uses Intel's processors, the requirements would be a faster processor, a power efficient processor, and a robust processor. There is a necessity of a microarchitecture with more efficient features. So what's a microarchitecture? A microarchitecture is a computer organization uh, in a computer in which the instruction set architectures are compiled on a processor. So in simple terms, it's the way in which uh, a simple the instructions are compiled on a processor. So we need a microarchitecture with more efficient features. And another requirement is to improve the customer satisfaction index. Uh, so next, uh, in order to compare the Intel processors, let's consider the recent releases of Intel, Haswell, Broadwell, and Skylake, with Skylake being the latest. Haswell processor was released in 2013, Broadwell was released in 2014, and Skylake was released in 2015. So Haswell and Broadwell are the processors which were more power oriented, wherein power efficiency was the main factor in designing the processor, whereas Skylake was more of performance oriented. By performance, I mean the speed. So if you consider two important factors in defining a processor, it's speed and power. So a processor should be as fast as possible with lesser power consumption. So Broadwell and Skylake are two processors which were referred to as TIC and TOC of Intel's releases. So TIC was the first product released in 2014, and a more developments were carried out on the Broadwell to release Skylake in 2015. So Haswell was based on 22 nanometer technology, whereas Broadwell and Skylake were based on 14 nanometer technology. What is this process node which we have been talking about? 14 nanometer, 22 nanometer. So if you take a semiconductor process, it's the set of steps that we carry out in manufacturing an integrated circuit. So if you take a process node, it's a standardized process which we carry out in manufacturing an IC. So it is standardized because it is easier, and moreover it improves the yield and the performance. So how is this named 22 nanometer, 14 nanometer? So the naming convention is simple. It's based on half pitch. So if you take a look at this picture, uh, the one which is to the right is 22 nanometer process. So half pitch is half the distance between one transistor and the another transistor with respect to a particular feature. So if you see, the half pitch of a 14 nanometer process is lesser compared to a 22 nanometer process, by which I mean the lesser the process node, the lesser the half pitch, and hence the smaller the size of the transistor, which eventually leads to improved density and hence better performance. So let's let us consider the features of the architecture. In this slide, I'd like to discuss the improved features of Broadwell over Haswell. So, die shrink. This is what I was referring to in the previous slide in 14 nanometer technology. So, what do you mean by die shrink? Here, we are using a transistor with a more scaled device. By scaled, I mean we are reducing the dimensions of the transistor so that we can fit more transistors in an IC. So as a result of which, more the transistors in a limited area, better the performance. So because of this, there is 5% increase in IPC, that's instruction per cycle, and there are other additional features. You can see from the graph that if you take over a span of 10 years, the number of instructions that are executed in a second has increased. So now let us consider the features of the Skylake. So Skylake is as we mentioned earlier, it's the top model of the Broadwell, but it is built around a totally new 40 nanometer technology, and it features two main new features, which are a Gen 9, that is a Generation 9 integrated graphics card, which has 30 times more or improvised performance compared to Broadwell, and also a DDR4 memory. So the earlier processors used DDR3 memory, whereas Skylake used DDR4. What is the difference between these two memories? It is basically number of transfers per second a memory can do. So if you see a DDR4 memory, it can do 2133 million transfers per second, whereas a Broadwell could do around 800 to 1000 million transfers per second. So by this, we can definitely see the improvisation in the microarchitecture of Skylake. So now let us consider the power efficiency of the Broadwell processor. So like if you see the power efficiency, it uses a second generation FIVR that's fully integrated voltage regulator, and it has better efficiency, and these were moreover power oriented processors, hence it has a better regulator, and hence there is lesser power dissipation compared to its previous processors. So if you take a look at the power efficiency of the Skylake processor, it's like compared to a Broadwell or a Haswell, Skylake processor has comparatively more power consumption, but that comes at a price. The performance of the Skylake processor has been really good. If you take a gaming desktop which is based on Xeon processor, it would consume around 91 watts with a speed of 60 times more than the Broadwell processor, which takes around 4.5 watts. But now let's take features of Skylake. Skylake takes around 10 to 20 watts of power, but it provides a speed which is around 60% faster than the Broadwell. So by this, we can see that use of Skylake processor is much recommended than a Xeon processor which takes 91 watts, or than a microarchitecture which takes 4.5 watts and runs 60 times slower than a Skylake processor. So now let's take a comparison based on the performance. So boost algorithm, these are the algorithms which are used in an architecture to improve the speed, and power gating is one more technology which is used to minimize the power and hence enhance the speed. So clock speeds were like conserved when in idle mode. By this I mean, if you're not using a particular feature of a processor, the supply of the power to this clock devices were cut down, as a result of which the speed improved. And if you look at the numbers, Broadwell operates at 800 megahertz to 2 gigahertz, whereas Skylake operates at 3 gigahertz to 4 gigahertz. And the curve curve shows that as well. Now take a look at the cost per transistor. So it can be seen from the figure that as the technology has improved, by which I mean uh, like the scaling has been improved from 130 nanometer to 10 nanometer, the number of transistors which are integrated has improved, and hence the cost has been reduced. Uh, now, so now let's take a look at the advantages of Skylake over Broadwell and Haswell. It's simple. It's performance, isn't it? If you take even mobile-based applications, it's 2 times faster than the other two processors. If you take a GPU, it's 30 times better. And it has a better memory allocation, DDR4, like we discussed earlier. And in fact, it has superior power efficiency. Now, let's take a look at the customer satisfaction index. This factor was introduced based on the feedback of the clients and the laptop manufacturing companies which use these processors. So it is known that the speed of the Skylake processor is like way better compared to Haswell or a Broadwell, but it comes at a price. The price being the heat dissipation. So if you take the number of cycles per instructions per cycle, Skylake has too many instructions, as a result of which it has more power dissipation. Hence, we need a better heat dissipation system, that is a better sink which takes off the heat from the laptops. And overall, to conclude, so performance wise, Skylake is way better because it's a performance oriented processor. All the microarchitecture features were changed accordingly, whereas Haswell and Broadwell were power oriented processors. And use of 14 nanometer technology by Intel, it's a very good welcome sign into the processor market, because other companies didn't use this technology and their speed and other features were comparatively slower when it is compared to Intel. So Intel's 14 nanometer technology can be considered as a superior technology in the processor based companies. Hence, companies need to adapt this technology to meet the requirements of the processor market. So that's it. Thank you. Thank you for your time.